Hello students, let us discuss the concept of exponential function and half time. This is a very powerful mathematics concept to solve the problems where exponential functions are involved. Let me take some random function. Let us say if some function n is equals to n naught e power minus lambda t. What is the meaning of uh, n naught, n and lambda and all this? See, lambda is basically a constant, some kind of a constant. Here t represents some time or anything like that. Here n represents final quantity, and n naught final quantity, or we can also call this as quantity at time t. Quantity at time t, and n naught is equals to initial quantity. In this situation, there are some observations that we can do with this function. There is a first important term. First, I will rearrange this. I can write this as n by n naught equals to e power minus lambda t. Then if I apply ln on both the sides, I will get ln n by n naught equals to minus lambda into t. Because if you wonder how we got this, I will write ln e power minus lambda t. So we will get ln n by n naught equal to minus lambda t. So this is the one function that we get. Once we write it in this form, now what is this half time? Half time means it is the time. So let me just copy paste here. So half time is basically time after which the final value will be equal to the n, the quantity becomes half of the initial value. So n becomes n naught by 2. So this is called half time. Now let me take this negative sign to the other side. If I take this negative sign also to the other side, we'll get ln n naught by n is equals to lambda into t. So let us substitute. Let n is equals to n naught by 2. Then t is called as half time. Generally for half time we indicate with t half. Okay. So if I write it, we know n is n naught by 2. So what will n naught by n will become 2. I'll just n naught by n means bring this n to this side and 2 to the other side. Okay, so you'll get n naught by n equals to 2. So let us substitute ln 2 equals to lambda into t half. So then what would t half would become? Half time would be equals to ln 2 by lambda. This is a very powerful expression. With this expression, we can solve many questions. What is the importance of half time? Half time remains constant whether n naught becomes n naught by 2 or n naught by 2 further becomes half, n naught by 4, and it further becomes half, n naught by 8, and so on. I will give an example. So we finally got if n equals to n naught e power minus lambda t. See, this exponential function has a nickname. This is also called as a decay function. That means with the time, the value of n keeps on decreasing and eventually it becomes 0. So whenever you have a decay function, and if you know lambda, so its half time would be ln 2 by lambda. Once we know its half time, we can also write this as 2.303 log 2 by lambda. Once you know this half time, what is the advantage? The advantage is, he will ask you an example. He will ask you find time taken for some 3/4 decay. That means 3/4 of the n naught should be destroyed. If 3/4 got decayed, what would be left out? So n would be just n naught by 4, because 3/4 has been decayed. That means it has been lost. So if n would be n naught by 4, if I what is the time taken we have to find. To find the time taken, we don't substitute here and solve it in traditional method. We'll just write something called arrow method. What does arrow method says is that, suppose if you have n naught, from n naught to n naught by 2, it takes t half. And again, what is the time taken from n naught by 2 to n naught by 4? It would be again t half only. It doesn't matter what is the initial quantity. To make it half, it will exactly take t half only. We can actually test it out and see it, and again it would become n naught by 8, and this process would go on forever. So if I ask you what is the time taken for 3/4 of the decade, so you can say half decade, another 1/4 decade. So the time taken would be, so the answer would be t half plus t half, 2 into t half. So the answer would be 2 into ln 2 by lambda. We can give one more question. Example, time taken for 40% of initial quantity, some 40% of the quantity is there, to become 10%, okay, or 10%, or we can say 5%. Then what should we do? Originally it was 40%, finally it was 5%. So let us use our arrow method. 40%, if I take first t half, it would become 20%. Again, next t half, it would take 10%. Next t half, it would take 5%. So what is the total time taken? Time taken would be 3 times the t half. So once it is 3 times the t half, 3 times the ln 2 by lambda. Let us see one application where we use it. One application could be charging and discharging of a capacitor. So a practical application in JEE mains is, JEE mains or any competitive examination would be charging and discharging of a capacitor. Let us say, if we take discharging of a capacitor, you will get the equation as the charge at any given time would be our original charge Q into e power minus 1 by RC into T. So this is the equation we'll get. Q is equals to Q into e power minus 1 by RC into T. Here we can clearly see the lambda value would be 1 by RC. Okay. Same thing I can extend to current also. What is current? During discharging, it would be minus dq by dt. So if I differentiate it, you can do it yourself. So it would be q by RC e power minus 1 by RC into T. So I can call this q by RC as I into e power minus 1 by RC into T. I can call this as I naught e power minus 1 by RC. Here also lambda did not change 1 by RC. But if I find energy during the discharging of a capacitor, for energy, the analysis would be q square by 2c. So I can write 1 by 2c into q square e power. If you square minus 1 by RC into T whole square, you will get minus 2 by RC into T. Okay, if you want, I'll do it again. So listen to this carefully. 1 by 2c, I'll do step by step. Q into e power minus 1 by RC into T. Now we have to square it. I think you know this formula, a power m whole power n. A power m whole power n is a power m into n. Okay, if you have negative sign in the power, it won't become positive. If you have negative sign here, it would, when you square it, it would become positive. If you have negative sign in the power, it won't become positive. Okay, so e power minus 1 by RC into T into 2. So you will get a power mn. So q square by 2c into e power minus 2t by RC. But here, as you can see, the lambda value would be q square by 2c. So the lambda value would be, let me call it, since I called lambda, for this case, the lambda value would be my 2 by RC. So each fellow has a different lambda. I hope you understood what is half time. And in the next problem, we can see one of the applications of this half time. I'll continue. Let us see an example where we can use this concept of half time to solve the problem. So let us see a JEE mains questions that was asked in capacitors. A capacitor is discharging through a resistor R. Consider in time t1, the energy stored in the capacitor reduces to half the initial value. So he's saying in time t1, the energy stored in the capacitor reduces to half the initial value. So let us write what is the energy stored in the capacitor formula. So we can write, I'll take this image here for reference. So we can write, we know just now we found what is the energy stored in the capacitor. Energy stored equals to E naught e power minus 2t by RC. And for this, what is lambda? The lambda value would be, I will write lambda, that is the constant is minus, it is 2 by RC. This would be the lambda value of this. So the time taken so that the energy stored becomes half of the initial value. That's what half time, right? We have found. T half for the first case, which is given as T1, would be ln 2 divided by lambda 1. Lambda 1 means 2 by RC. So I can write RC ln 2 by 2. So this would be T1. Now next one, what does T2 represent? Here he has given in time T2, the charge stored reduces to 1/8 of the initial value. He is not saying energy reduces to 1/8. Charge reduces to 1/8. For charge, we know the equation is Q equals to Q or Q naught e power just minus T by RC. The lambda value of charge is different. Okay, it is 1 by RC. So first we have charge Q originally. First it becomes Q by 2. Then it becomes Q by 4. In next half time, it will become Q by 8. So what is the total time required for this? We need 3 half times. One half, second half, another half. So we need 3 times the half time. But remember, while writing the formula for half time, we have to use the lambda of that particular function. You cannot take lambda of energy and use it for this. Okay, we know lambda for this would be 1 by RC. So from this, we'll get 3 RC into ln 2. So we got T1 as RC by 2 into ln 2, T2 as 3 RC by ln 2. Now we need, the question is actually to find T1 by 2. So let us try to find the value of T1 over T2. So if I try to do T1 over T2, so you will get RC by 2 into ln 2 divided by T2 value is 3 RC ln 3 RC ln 2. So 1 by 2 by 3. So it would be 1 by 6, which would be option D. So once you know the concept of half time, these kind of problems, we can solve it very easily. I hope you understood what's the importance of half time and what is half time. Remember, whenever we have an exponential function, any exponential function, this is also called as a decay function, we use the concept of half time, which is ln 2 by lambda, to solve the problems easily. What does half time says? Anything, whether it could be percentage or a literal number, to become half, whatever is the time required, n2, n0 by 2, n0 by 8, n0 by 16, n0 by 32, and so on. Hope you understood how are we supposed to solve this problem. Thank you.